Hello, I'm Mrs. J, and today we're going to go over horizontal and vertical asymptotes. So in this section, they just want us to find the vertical and horizontal asymptotes. Remember, before you can find those, you need to find the domain. To find the domain, we set the denominator equal to 0. If we do that, we have x squared equals a -9. And notice we'd want to take the square root next, but this is going to be imaginary numbers. And so for graphing, that's not going to work. So there's no value omitted, which means the domain is a member of all real numbers, or negative infinity to positive infinity. Well, that means there's no vertical asymptote, because if nothing's omitted from the domain, there's no vertical asymptote. To find the horizontal asymptote, you look at the degree of the top and the degree of the bottom. The degree of the top is 1 and the degree of the bottom is 2. When the degree on the bottom is larger, the horizontal asymptote is y equals 0. So there's a horizontal asymptote at 0, but there's no vertical asymptote. And I think they just have you, yeah, you just graph the 1, then you would just, they'd probably, yeah, there is no vertical asymptote. I wasn't sure how they'd ask you. Let's try another. Oops, we don't want the answers though. Okay. Negative 2x squared over 2x minus 5. So on this one, our domain (2x minus 5) equal to 0, because we can't have the denominator equal 0. Our domain is x cannot equal 5/2. Now if we go back up here, this top is not factorable, so this factor will not reduce. Because it doesn't reduce, there's a vertical asymptote at x equals 5/2. To find the horizontal asymptote, we look at the degree of the top, which is 2, and the degree of the bottom, which is 1. When the degree on the top is larger, there's no horizontal asymptote. There's a slant asymptote. I'm not sure if they want you to do that here, but we might as well find it. To find the slant asymptote, you divide. So we would take 2x minus 5 and divide that into negative 2x squared minus 3x. We need a negative x. So we need to multiply negative x to get a negative 2x squared. But we're subtracting, so we're going to change this sign and then distribute. So we'd have 2x squared minus 5x. These cancel and leave, whoops, there wasn't an x with this. Negative 5x minus 3. What would we need to multiply negative 2 by to get a negative 5? A negative 5/2. Because if we multiply these, we'll get negative 5. So we need to multiply by a -5/2. 2. Because we're subtracting, we want to change our sign and then distribute. And you have 5x minus 25/2. This cancels. This you don't really need to worry about. If you wanted, it's -31/2, but the remainder we don't worry about. We know that it will approach this line. And so this would be our slant asymptote. I don't think they're looking for that in this section. I think you just say that there's no horizontal. Yeah, there's only a vertical. But we will need this, so I wanted to go over it. Try one more. That looks nice. F of x equals x minus 1, 2x squared, minus 6x minus 8. We can pull a 2 out. And it is factorable. X minus 4 and x plus 1. It's up to you if you factor it here or you factor it when you're finding your domain, but you're going to have to factor the bottom anyways. You tell that's a, this is x plus 1. There we go. Okay, I thought these were going to cancel, but they don't. So the first thing we do is find our domain. Domain, you set the denominator equal to 0. So for our domain, x can be any number except for 1 and 4. And that would be set notation. But x cannot equal 1 or 4. Now since these do not reduce, because this is a plus 1, both of these are vertical asymptotes. So we have a vertical asymptote at x equals 1 and x equals 4. For the horizontal, we look at the degree. The degree on the top of this one was a 1. The degree on the bottom is 2. Because the bottom is larger, the horizontal asymptote is y equals 0. And that was good. We covered every case of the horizontal, so that worked out good. Fine. 1, 2, 3, 4, 5. This one. Okay, so this one you're looking at the graphs and finding information. So they want us to, let me open this up. Assume that all asymptotes and intercepts are shown and that no graph has holes. Write the equation for all the vertical and horizontal asymptotes. Enter the equations using the AND button as necessary. So vertical asymptotes are asymptotes that are going up and down. Notice there's two of them. There's one at -2. So we have a vertical asymptote at x equals -2. And then we have one at 4. So x equals -2 and x equals 4. The y is here right on the axis. That's where y equals 0. So the horizontal asymptote is y equals 0. Find the domain and the range. When you're finding the domain, you're going across the x. So it's whatever's omitted here gets omitted. So our domain is -infinity to -2. Right answer as an interval or union of intervals. So they probably want U for union. -2 to 4 and union 4 to infinity. Running out of room. The horizontal, the only thing omitted is 0. So that gives us our range, -infinity to 0 and 0 to infinity. X-intercept, well, there isn't an X-intercept. Oh, there is one right there. Notice that even though it's the asymptote on some functions, and there's not very many of them, but on some of them it will cross. And so we have an X-intercept at 3. So you would mark the 3. Y-intercept is where it hits the y-axis, and notice it's at 2. Let's try another one. So the first thing, vertical asymptotes. Notice there's two of them. One's at -3. And one is at 2. Horizontal are y equal, and y equal again is on the axis, so y equals 0. For the domain, I think that's what they asked next. Yeah. Domain, the only thing omitted is these two values. If you want to think of the number line, it's everything except for them. So it should be 3 parts. -infinity to -3, -3 to 2, and 2 to infinity. The range is everything except for 0. So that's why it's 2 parts. So for the range, it goes -infinity to 0 and 0 to infinity. The x-intercept and the y-intercept. X-intercept, it's crossing here at 1. And the y-intercept, it's crossing at 2. They just want the value. So that's all there is to those.